Hi everyone. My name is Maren Tahan. I'm a network software engineer at Intel, and my main focus is working on platform service assurance. So today we are going to talk about how you can monitor your DPDK application with CollectD. And before we dive into how you can monitor your application, we're going to talk a little bit about why would you want to monitor your application. Then we'll dive into details of how you can do that. We have a little demo for you then. And Emma's going to show us the demo, and she's also going to talk to us about how you can get your metrics and events to OpenStack. And we'll just wrap up after that. So, why would you want to monitor your application? As the world becomes increasingly dependent on the internet, data centers have come to power our everyday lives. And the financial implications of data center downtime are actually outrageous to a certain extent. 1 hour of downtime can cost an organization an average of $138,000. And actually, I saw a more recent stat that said something like, for 70% of organizations, it actually costs upwards of $300,000 per hour. So because of that, telco and enterprise are asking, how can they get and provide service assurance as well as QoS? How can they provide SLAs on the platforms and services when they're deploying NFV? If the fixed function appliance is going to be replaced by a virtual appliance, then the service levels, the manageability and the service assurance needs to remain consistent with what's available today or even improve on it. Lack of service assurance is really a barrier to NFV deployment and adoption. So because of that, it's vital to monitor systems for malfunctions or misbehaviors that can lead to service disruption, and we need to be able to promptly react to these faults and events in order to minimize service disruption and downtime. And that's a scientific fact. So how can you monitor your application? Well, CollectD is one possible tool that's out there. There's another one called Snap, but I'm going to focus in on CollectD today. And if anybody's interested in Snap, I encourage you to come and ask me about it afterwards. CollectD is a system statistics collection daemon. It's been around for more than 10 years. It's used in a wide number of telemetry frameworks. It has a plugin architecture, which we're going to dive into in a moment. It supports more than 90 plugins, and it can even provide some simple thresholding and event notification capabilities. Sorry, we skipped ahead a bit there. So the architecture in CollectD, with the architecture of CollectD, you can actually divide plugins into a number of categories. You have input plugins, which collect statistics from the system. You have output plugins, which publish the statistics collected by the input plugins. They can be to file locally on the system, they can be to a database, or they can be off to another endpoint or platform. And you also have binding plugins, which allow you to write plugins in different languages. Notification plugins, which allow you to send events based on thresholds that you preset with the daemon for certain stats that you're interested in doing thresholding on. Or they also support direct eventing. So if your plugin that is a read plugin is used to monitor an event, then once you dispatch a notification, any notification plugins will directly submit that to the endpoint that they're talking to. There's also logging plugins, and these are actually for the daemon itself. So they actually just output messages from the daemon syslog or log file, but they do have other plugins that allow you to actually tail log files as well. It's called tail. And then the last category of plugins we have are input and output plugins, like the Unix SOC plugin or the network plugin or the MQP plugin. So what we did was we actually developed a couple of plugins for DPDK. The first one it leverages the xstats API. It's a DPDK stats plugin. It runs as DPDK secondary process, and it's capable of retrieving statistics for the IGB, IGBE, the IGB, IXGB, I40 and FN10K interfaces, or any other interfaces that support the xstats API. It's been merged into CollectD. It's actually there for a month now, and we're actually working on a similar plugin for SNMP, which is another telemetry framework for cloud, and that'll be upstreamed shortly as well. On the eventing side, we wrote a plugin that uses DPDK Keep Alive to report packet processing core status, and this events plugin is also capable of reporting link interface status, or link status for a DPDK interface, and both of these will be available very, very shortly on the CollectD GitHub. So at this point you're thinking, wow, that's a lot of information, but you still haven't told me how I can monitor my application.
That's all. So now we're going to have a look at a demo so you can see some of the stats that are available with through CollectD, and then we're going to have a look at how that actually works in OpenStack and see it running as part of a larger system. So the demo we're going to show has our traffic generator generating traffic into test PMD as our DPDK application. CollectD will pull statistics from this application, write them out to InfluxDB, and Grafana can pull from there and graph the results. So we're seeing some traffic going through the system now. This is good traffic initially, and you can see top, middle, there's no errors happening. Right, so now we're going to start the bad traffic going through the system. You'll see a pie chart up in the top right showing the types of error that are occurring. Okay, so initially we have oversized packet errors, undersized packet errors, and we're seeing some CRC errors coming through now. So this is great and all, but you want to know how you can use this in a larger system to do more than just view what's going on. So this is where OpenStack comes into it. And for anybody that's not familiar with OpenStack, it's a set of tools for managing and provisioning cloud computing systems. It consists of, but it's not limited to, projects for managing compute, storage, and networking. So this is in the context of CollectD again, and we're going to look at your DPDK application running alongside OpenStack, which is here on the right. And the way CollectD works is you set an interval. At a particular interval, it'll pull all the plugins on the system that are registered to collect data. So when this interval expires, we'll go to the DPDK application, gather the statistics, and once that's completed, all the plugins that are configured to output information will be activated. In this case, it's the CollectD Ceilometer plugin, which is taking the CollectD data, parsing it to a format that OpenStack understands, and posting the results to the Ceilometer API currently. So this, in this way, you have the statistics available to OpenStack, so that any application running on top of it can actually make use of these statistics for fault detection, fault monitoring, and in this way you can improve the service assurance capabilities of your platform because you now know what's going on. so almost there. In summary, trying to manage a complex cloud solution without proper telemetry infrastructure is like trying to cross a busy highway with blind eyes and deaf ears. You have little to no idea where you came from and no chance of taking any smart move without getting into trouble. So with the work that's been done, that's been outlined here, you can now monitor DPDK applications and leverage these plugins for Snap and Collect D to monitor your platform and to analyze performance, detect faults, and failover in the case of something bad happening. So these metrics and stats that are collected by DPDK and Collect D fit into a larger service assurance picture, which includes OBS, IPMI, information about your bias, and many other platform features. So, finish off, I'll leave some open questions to you guys, like what kind of SNMP support is required or preferred in DPDK, and do you want to see DPDK having its own MIBs or fitting into an existing framework? Questions?
I was going to say, or even if anybody would like to have a chat about our other questions, that would be good as well.
So, my question is about what happens when the the primary DPDK process goes, is terminated.
Oh yeah, back there. Yeah, so actually what we're doing is we're forking off the DPDK secondary process. We continuously check the liveliness of the primary process every time the read is called, and if the primary dies, we actually terminate the secondary process that's running, and as soon as we detect the primary again, we shoot up another secondary.
Perfect, thank you.
No problem.
Okay. Yeah, please.
We have a question up the front first, sorry.
Yeah, go for it.
My question is about the performance impact when it's collecting the data that is impairing performance.
Yeah, so the question was, when we collect the data, does it impact the performance of the DPDK application? We ran a performance benchmark that actually was very intrusive, so we retrieved xstats at a 5 millisecond pace, and we saw less than a 1% impact on performance. Yeah.
Okay, so first of all, I saw that your main commit went in like end of September or something.
Yes.
And 5.6 was released of Collecti early September. Do you know if it's in 5.6.1 or only will be in 5.7?
It'll be in 5.7 with an update, hopefully. We're trying to migrate into the latest version of DPDK as well, so we should see that soon enough.
With the latest, do you mean 16.07 or planning for 11?
16.07, and as soon as 16.11 is available, it'll be pulled in as well.
Will it be backward compatible to 16?
Yes.
Okay, that's great for a start. So I think we can make that into Debian and you will do it rather easy, so that's why I'm heading for. I think you can drop most of your documentation because you don't need to build Ubuntu anymore. So I think I'll contact you later on to make that happen. But one question for applicability in the field.
Yes.
It has, and that's not so much a Collecti, but more DPDK secondary processing, that you have to disable address space randomization. Is there any work on getting away with that? Because it's kind of a, yeah, that would be nice, but no go.
I'm not sure yet.
So it's a general thing on a secondary process in DPDK to disable ADSLR. Is there anyone?
So we were actually thinking about being able to wrap up a lot of the stuff that we need under another DPDK API, but that's still a work in progress. We're kind of designing it in the background, but to be honest with you, it's something that's just kicking off internally, and hopefully by the time 17.05 even comes along, we'll have something in place for it.
Okay, thank you.
No problem. But the ASLR stuff was challenging.
Do you see Collecti being used both for VNF monitoring and infrastructure monitoring, or only one of them?
Yeah, so Collecti is actually widely used as part of a lot of existing telemetry frameworks today. So by unlocking these kind of read side plugins, you also unlock the capability to retrieve even more stats from the platform, including DPDK relevant stats. So it's very, very widely used, and because of that, we're integrating with it and supporting it.
With the xstats being put in now for vhost ports, will it work with vhost?
Yeah, so you have actually two options for, I assume are you talking on a DPDK level or an OVS level or both?
DPDK.
Yeah, it will support vhost xstats API as well. On the OVS side as well, we have separate plugins for monitoring OVS stats and events. Per interface, they subscribe to the actual OVS DB, so they're agnostic of whether or not DPDK is running under the hood. But if you prefer to use the xstats API, you obviously get a lot more statistics if you are monitoring OVS with DPDK interfaces. Anything else? In that case, yeah.
I was just wondering about the MIB structure. So the MIB structure, you're probably only handling the MIB on the one side and the collectee side. It's not within the DPDK framework, I don't believe.
No, so what we were kind of planning on doing was doing the mapping of DPDK xstats to existing MIBs, and that's at a higher level. Yeah.
That's what I figured. Okay. So then the collection, you're basically taking collectee and having it plug on to the DPDK, grab the data, pull it back, because usually for MIBs you're using UDP.
Yes.
But you're not doing that, you're basically taking the data directly.
Not quite. So we're actually writing an SNMP plugin for collectee that receives notifications. So the current support in collectee is actually to poll for information. But the SNMP plugin we're going to write actually gets or receives a GET request or a GET next request or a SNMP walk request. collectee, on the other hand, on the other side, is already reading DPDK stats. So what this SNMP plugin will do is actually look up a MIB table. It'll know that when I receive this stat or this piece of information, it's associated with this MIB, and it'll seamlessly interconnect, or it'll seamlessly pull the values associated with the relevant OID and MIB and send it off the platform. So that's
I guess any of that process within that's touching the DPDK, it's not touching any system services.
No.
Okay, good.
It isn't. So my question to the community here is, has anybody even looked at SNMP support for DPDK? And if you have, do you see DPDK as having its own MIB, or should have its own MIB, or should it live under the remit of existing interface MIBs? Anyone?
So our product supports SNMP today, and we're supporting the standard MIBs because that's what the users out there expect. And that's what all their monitoring systems and so on support.
Yeah.
We also, in addition to that, have our own system MIB, and it's not interesting for the end users to see some lower layer details. For our system, and I guess probably many other custom systems, it's more interesting to present numbers that are relevant for the specific application rather than some internal queue sizes or whatever.
Okay.
It's not what customers want.
Okay, cool. Thank you.
Yeah, I would also say that you don't want to do your own MIB.
Okay, sorry.
I mean, having your own MIB is just a lot of work. And all the standard MIBs seem to give you everything you need. So.
Okay, cool. I've never been afraid of a lot of work, by the way, Keith, so...
Yeah, I know, but it's just a pain to do.
Yeah, I take that on board. Thank you very much.
Are these counters 64-bit or 28 bits? The counters that you're looking
Yes, are they 64-bit?
64-bit.
Yeah.
Just one quick note, you have to be really careful with MIBs. If you get into some of the MIBs, like the routing MIBs, they scale like crap.
Yep.
So You know, it seems like interface statistics are really easy. If you get to if you tried to do the LPM into one of the routing MIBs, you drive yourself crazy.
Okay, thank you very much. Okay, thank you very much, folks, then. Oh, sorry, there's one more.
That question is that you are asking for the DPDK's MIB supporting, are you talking about the port status or other things on that?
So interface information will be part of a MIB that's currently, supported today. Absolutely, stats is one aspect, but definitely information about interfaces is another for sure. And if there's a, stack, networking stack supported on top of it, we'd even consider looking at IP, TCP, UDP type MIBs as well on top of that.
Okay, Mariam, Emma, thank you very much.